Yeah, good morning students. Today we will learn how to find out the refractive index of liquid, let's say water, using what? Concave mirror. So this is the ray diagram. First we have a concave mirror, okay, concave mirror, and this is the concave mirror we are using, okay, and this concave mirror is placed on this particular mirror, plane mirror, and we have this needle, okay, this is the needle. So first, this is the system. First we'll use the needle as an object and we'll move this needle over here up and down on this, what is the axis, principal axis, such that you will get the inverted image of this one and the inverted image of the needle, and the needle moves like this. This is called as parallax removed completely, okay, from tip to tip. So this complete distance is my this PC, and which acts as the real depth or the real distance. So when the object and image coincides, I can easily say that this distance is what? The center of curvature. This complete distance is the radius of curvature. So later on, we will put over here water, okay, and we need to calculate the refractive index of water. We'll put the water over here and again repeat the same, what is say, method, that is moving this needle up and down and finding out what the position where the inverted image coincides with the needle, okay. And when that is done, this is the conditions over here. This is the real needle, this is the inverted image. So when this is done, we'll calculate this, what is say, we'll measure this particular distance, PC, this distance, and this called as what? Apparent depth. And using the formula that the refractive index of medium is easily calculated by the real depth upon the apparent depth, okay. So now I'll tell you how to take the reading. Yeah, so I have kept a mirror over here, and on the top of the mirror I'll keep this concave mirror, okay, and this is the, what is the stand, and this stand represents the principal axis, and this is the needle, and this acts as my object, okay. So what I will do is I'll move this part and fix up a position where the image of this needle on the mirror coincides, and then these two moves what, like this together, okay, and I'll measure that distance with the help of this meter scale, okay, and this reading will be my first reading. That reading is my the center of curvature reading, okay. So let me first adjust this part. See, now this is moving like this with the object. So this is the object needle, and the image is inverted, and they are touching on tip to tip, and they are moving like this. When I'm doing like this, they are moving like this. So it means what? Parallax between the object and the image is removed from tip to tip, and then I'll measure this particular distance from the top of the mirror to the tip of the lens. Right now it is coming nearly to 15 centimeter. Okay, so now what I will do is, now I'll put some water on this mirror. So please make sure that you are putting a very few drops of the water over here on the mirror, okay, such that over here the mirror layer, on the top of the mirror a water layer is created. And once again I will do one thing, I'll repeat the same procedure. So I'll find out the image and the object should be moving together. I'll put little more water. A good layer should be created over here, and there should not be any air gap remaining there. See, now this is the object and the image. Once again they are coinciding. Object and the image, they are coinciding on the liquid layer, and then once again you measure this particular distance from the top of the mirror. So remember that it has to be lesser than the first reading. Now it's coming nearly to 12, okay, and then this is called as the apparent, what is a position, and or the apparent depth. So using the formula refractive index equal to the real position upon the apparent position, you can calculate the refractive index. Yeah.